The building is the Mackie building, built in 1879. Originally it was the Chamber of Commerce building for the city of Milwaukee, and for the last almost 140 years it's operated as an office building. So historically it had been on steam. It didn't have any cooling. At some point in time there was a split system that was not in any way, shape, or form energy efficient.
The Mackie building was a retrofit. It's a beautiful building inside and out, but that had a lot of design restrictions. And on top of that, they also had a lot of different tenants.
No other building in Milwaukee has so many occupancies. We have not only 25 residential units, we have an assembly space for 150 people, we have commercial space, we have office space, we have restaurants, and we really needed a system that could comprehensively address and function all of these spaces.
The LG VRF system gave us that capability to meet all of those demands.
The system is very conducive to being retrofitted into an old building. We were able to zone each floor, zone each unit, however we needed to accommodate those different uses.
We had to be careful on the project. There were requirements from the National Park Service for the historic rating of the building. Walls are 2 to 3 feet thick. Floors are wood in some areas, concrete and stone in others. It's very difficult to route large ductwork or large piping systems throughout the building.
So VRF is perfect in the fact that I'm not running large ductwork through the ceiling. I now have just maybe 1.5 inches of pipe that's going to be running throughout the space. So that gave us the flexibility that we needed.
From an adaptive reuse perspective, we really needed every square inch of this building to make the numbers work. So the idea of having mechanical closets, chewing up 70 or 80 square feet or whatever it is in every unit wasn't really economical.
The system also had a lot of flexibility that allowed us to really be in conspicuous areas without really sort of jeopardizing the look and feel of some of the high quality aesthetic spaces.
So in this particular building, we were able to utilize the clock tower, and we were able to house our outdoor units in that space.
And we identified it as an opportunity to locate the air-cooled condensing units inside and provide some heat in that space to meet the heating demands all the way through the wintertime.
So we were actually able to use a VRF system without having a redundant heating source throughout the building.
The LG VRF system is able to maintain an efficiency of above 3 COP, which is incredible performance in heating. We were able to put some louvers on the side with some dampers. They open up in the summer, and then the units are ducted up through the top and they exhaust that air out, so they keep that airflow circulating. In the winter, we then close those intake louvers. We open a recirculating damper, and that airflow now recirculates in the space while a gas unit heater turns on, maintains that space temperature, wherever the owner would like to keep that space temperature at. So on the first floor, there's a restaurant, and it's one of those iconic historic taverns in Milwaukee that everyone knows, and they had no places for us to place equipment or ductwork or anything like that. There was no closets to utilize. So we were forced to use a wall-mounted unit. Thank goodness that LG has developed an entire line that's dedicated to creating aesthetically pleasing units. So even if they're exposed on the wall, they're intended to blend into the space. So in that particular space, we used a near finished wall mount unit, and it's secondary. It just blends into the bar area.
It really showcases a building that really required not only infrastructure system, from mechanical heating and lighting, all the way to reviving its beautiful architectural details.
And incredibly, the LG VRF system gave us that capability to meet all of those demands as we were going through the installation process.